Okay, so on these, we're going to really focus on translating from English to math. So it says the length of a rectangle is 3 feet less than, or something reduced by 3 feet, double the width. And the area of the rectangle, which happens to be length times width, because it's a rectangle, is 14 square feet. And we know it's square feet because it's area. When you deal with area, you're dealing with square feet, square inches, square meters, square miles, that kind of thing. All right, so what are we going to do here? How are we going to solve this thing? Well, we look around at what we've got and we say, I've got one variable already isolated, which means that in this problem, L and 2w minus 3 are always interchangeable. They're the same. So I can take what this isolated variable L is equal to 2w minus 3 and plug it in for L in the other equation. So that this equation here becomes length, which is 2w minus 3, times width equals 14. So you'll notice all I did was replace the L here with what L equals, 2w minus 3. Now I can go ahead and solve it. So multiplying away the parentheses, I get 2w squared minus 3w and equals 14. And then I can subtract the 14 from both sides. Yeah. And then I can either try quadratic formula, or I can try completing the square. Well, those will both work. Or I can try factoring, which may or may not work. Or I can try doing it on the calculator. You know what? I haven't done it on the calculator for a little bit. Let's do that. Okay, so I'll get 2x squared minus 3x minus 14. Okay, and I think we're looking good there. So let's clear that stuff out. Okay, that was the left side of the equation. The right side of the equation is 0. Actually, you know what I would prefer? Yeah, okay, yeah, that's right. Okay, and then I'm going to go to, what am I going to go to? Yeah, the graph. Okay, and I'm looking for where they intersect, because that's where they're going to match or be equal. So I'll go second trace 5, enter, 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 and I get one solution of -2. And second trace 5, bring it around the horn, enter, 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 and I get 3.5 for my other solution. And that would be how to do it on the calculator. I want you to be able to do it by hand and by calculator. All right, now let's take a look at this Pythagorean Theorem stuff. All right, the longer leg of a right triangle is 4 inches longer than the shorter. The hypotenuse is 8 inches longer than the shorter. Find the side lengths of the triangle. Okay, you'll notice first the easy part. There's 3 sides that we're talking about, which makes sense because, well, we're talking about a triangle. Okay. Now, you'll also notice that in the first sentence, the longer leg is being compared to the shorter leg. And in the second sentence, the hypotenuse is being compared to the shorter leg. So the easiest way I found to do this is to say, all right, what side are they being compared to? Well, 2 of the sides are being compared to the shorter leg. So the shorter leg, I'm going to call that x. Okay, so I'll write it over here. Okay. You don't have to do it that way. I just find it easier. Okay. So since the shorter leg is x, the first sentence says the longer leg is 4 inches more than that. So the shorter leg increased by 4. And the hypotenuse in the second sentence says it is 8 inches longer than the shorter. So the shorter leg increased by 8. Okay. Now we've got, now the problem is not going to be as hard as it would have been. Okay. But that's how to do it. That is how to do it the easiest way I know how. And that's going to work every time on these. Okay, so the Pythagorean theorem says that that one leg squared plus another leg squared, don't forget your parentheses, is equal to the hypotenuse squared. All right, now to do this, we got to multiply stuff out here, okay? So x plus 4 squared is just x plus 4 times x plus 4, which ends up being x squared plus 8x plus 16. All right, and then this last binomial squared is x squared plus 16x plus 64. All right, so now we want to get everything on one side. So if I subtract x squared from both sides, those are gone. Cool. And if I subtract 16x from both sides, I'm going to get that. And if I subtract 64 from both sides, I'll get that. At least I hope so. 40, 50, 64. Yeah. Okay. Now I've got just a regular old Pythagorean or a quadratic equation. So I can do it on the calculator. I can do it by the quadratic formula, or I can factor it if it does factor. I think it does. I think x minus 12, x plus 4 will get the job done. And when we set this factor equal to 0, we're going to get 12. And when we set this one equal to 0, we get -4. Now, we are looking for lengths of sides, and x stands for the short leg. Well, you can't have a negative amount, so it has to be 12 for the short leg. So x is 12 everywhere in this problem. So x is 12 there. And 12 plus 4 is 16. And 12 plus 8 is 20. And everything is measured in inches, so I'll slap those in there because numbers without units don't really mean much. And that's it, 12 inches, 16 inches, 20 inches. You got it. Okay, on this one, we launch a rocket up into the air at 50 meters per second. Okay, and so H stands for the height of the rocket. When? Well, depends on what you plug in for t. T is measured in seconds, and so if you want to know what the height is at 2 seconds, plug in 2 for t. If you want to know the height at 3 seconds, plug in 3 for t. Okay, and then the picture, that just says, hey, this is what's going to happen. No big deal. Okay, so find all values of t for which the rocket's height is 20 meters. So presumably, the rocket goes up and it comes back down. And if that's the 20-meter mark, okay, it hits the 20-meter mark one time, hits it again on the way back down. And we want to know what, what the first time is and what the second time is. What are those two times? Okay, so that is the idea. This 20 right here, are we going to plug that in for t or h? Well, it says 20 meters. Meters is height. Meters is distance. So we're going to plug that in for h. If it said seconds, well, we'd plug it in for t, for both of the t's, but it doesn't. Okay, so we're going to have 20 plugged in. And to be honest, for these problems, it usually ends up being a decimal answer. It doesn't usually work out, to be an integer. Okay, so I'm going to send the 20 on over. Red Rover, send 20 on over. I actually just played that again. It's been years. That was a lot of fun. Okay, so now we'll do, again, you usually get a decimal answer, so that means factoring is not likely to work. But you know what I could do to make things just a little easier? I am going to divide both sides by 5 because I see that 5 divides into both sides. Okay, so we'll get 0 equals 10t minus t squared minus 4. Okay, so now the numbers are smaller. I didn't have to do that, but it's kind of nice. All righty. So if so I'll say, all right, so t equals Pythagorean quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Well, I'll tell you what I'm going to do now. I'm going to get rid of all this just to, because I'm going to go to the calculator now and wrap it up that way. Okay. So let's go to the calculator. And I'm going to, I mean, this is just one way of doing it. Okay, so I'm going to go make a fraction worthy of Mordor. Okay. And then I want to go square root of 10 squared minus 4 negative 1 4 over 2 times 1. Okay, I think I typed it correctly. All right, so at 0.4 seconds, the rocket gets to the 20-meter mark. That's probably on the way up. I'm going to just arrow up, grab out the enter key, and then not type everything out again, and just change that to a subtraction. Okay, the rocket comes back down to the 20-meter mark at the 9.6 second mark. So 0.4 seconds and 9.6 seconds. So on the way up and on the way back down.